Good afternoon, everyone, and welcome to Boston Distance Education. This is MBF3C. Foundations for College Mathematics, Grade 11, College Preparation, and my name is Marvin. We are into week 2, and as we only have classes Monday to Thursday, this will be the last class for week number 2. So we are going to get into lesson number 3 today. It's on the screen, but before we do, in the middle of the screen, you can see my contact information, marvin.osmond@nnecschools.org, or you can call my cell phone number or text it, 807-738-2031. So the first unit deals with quadratics. And we've done 2 lessons, and now we're into the third one. So the first lesson, we looked at the vertex form of the equation. And now we're going to get into another version, and it gives us different information. So the vertex form of the equation, uh, we can use it for transformation, which we did in lesson number 2. So it gives us the vertex, where the vertex of the parabola would be, whether the graph opens up or opens down, and then was moved to the right or left, or up or down. And we get the vertex right from the equation as well. That's one form. That is a very useful form of the equation. That's probably the easiest. We're going to learn 3 forms of the equation, and the vertex form is the easiest one to use to help us visualize what the parabola is going to look like before we graph it. Okay, so the other 2 forms will give us different information, but the information is not as useful when it comes to drawing a graph. Now, they are useful in providing different types of information, which we'll see once we get into them, but not as useful for graphing. So we are going to, last lesson we looked at um, factoring trinomials. And we learn to factor trinomials because we need that for the next lesson, which is solving and graphing quadratic equations. So what we mean by solving a quadratic equation, and different terminology is used depending on the textbook you're reading or the online site you're visiting. It varies the terminology they use. But solving, essentially what you're looking for are the x-intercepts. So where does the parabola cross the x-axis once it's graphed? That's essentially what you're doing. Some people call it finding the zeros. Some people call it finding the roots. Some people will say find the x-intercepts. And other people will just say solve. So it depends on the context of the problem you're working on. And it will provide, as I said, this is a different way of, uh, we can use it to graph, but not as useful. So here's an equation, uh, the example that's in the module that you receive or the package that you received. Y equals x squared minus 3x minus 10. Now, I'm not going to go through the solution with you because it's written quite clearly in the lesson material. I'm going to just show you a couple of things, then I'm going to solve a couple of additional problems for you and to provide some extra examples. So what I want to do first of all is I want to graph this particular equation, y equals x squared minus 3x minus 10, and just to show that it indeed does provide, oops, it does give us a parabola. So y equals x, shift number 6 to get me to square that. Okay, where did it go? Y equals x squared minus 3x minus 10. Okay, so this one here produces this particular graph right here. Okay, so this is the graph that we get from this particular equation. Now you'll notice here that the y, where the graph crosses the x-axis, the y value will be 0. So crossing the x-axis, if I point to this one right here, it's going to be, it's actually minus 2 comma 0, and this one is 5 comma 0, and minus 2 comma 0. So the x-intercepts occur when the y value is 0. So if I put the y value of 0 into this equation and I solve for x, then I'll get x is going to be negative 2 and x will be 5. Now you notice the y-intercept occurs when the x value is 0. So this is 0 and negative 10. So the x value is 0 and the y, or the x coordinate is 0 and the y coordinate is negative 10. Now if you look at this particular equation as is written, y equals x squared minus 3x minus 10, if I make x 0, 0 squared minus 3 times 0 is 0, 0 minus 10 is minus 10. So in other words, the number at the end in the trinomial, in this case minus 10, will give you the y-intercept. So that's all we get. So if we didn't have the graph in front of us, and we knew that the y-intercept was negative 10, that's all we would know. And it's difficult to draw a graph problem when that's all you know. Does the parabola maybe flip over and is over here somewhere? We don't know. Okay, so again, that's all we get from this particular equation. Okay, so if I come back over here, again, the y-intercept occurs when x is 0. In this case, if x is 0, y is negative 10. So that's the y-intercept. So again, that number right here at the end, negative 10, will be the y-intercept when we're looking at this form of the equation. Okay? So when x is 0, whatever y works out to be, in this case minus 10, that will be the y-intercept. Now to find the x-intercepts, we have to let y equals 0. And then we have to solve for x. So when we solve for x, what we have to do is factor the trinomial and work from there. So it's laid out here, just a couple of examples laid out for you. I'm going to leave those. You can work through those on your own. So here's another example. So sample problem 3.1. Again, this is in blue and red, so it's new. So it's not in the package you've received. So it says solve y equals x squared plus 2x minus 24. So solve means find the roots, find the zeros, find the x-intercepts. It all means the same thing. So to solve this, what we need to do is to factor the trinomial. So this is the trinomial x squared plus 2x minus 24. So I set that, if I make y equals 0 and I solve the trinomial, I'll work through an example for you and then you'll see where we're going with. So if I factor the trinomial, but then we got to set that equals 0, okay, because, oops, 24, okay, equals 0. And we're going to solve that problem, okay? We're going to solve that trinomial. So we have to set, in order to solve the trinomial, it has to be equal to something. And in this case, we're looking at the y value being 0, because as I pointed out over here, when the y value is 0, in this case, minus 2 comma 0, when y is 0, x is negative 2, and over here, when y is 0, x is 5. So we got 2 x-intercepts. Okay. Now, there are going to be some cases where There might not be any x-intercepts. So if you were to think about, if I were to take this problem and I were to slide it all the way up so that the vertex is above the x-axis and opens upward, it will never cross the x-axis. Okay, so that is a possibility as well. Or if it opens downward, so if I were to, for example, if I were to simply make this a negative sign, now it opens downward and doesn't cross the y-axis. Okay, so there are a couple of cases where, and in those cases, if you try solving the equation, you won't be able to solve it. But we're not going to worry about those. We're just going to worry about a couple of these right here. So now in order to solve that, we have to factor. So when we factor, we're looking at two integers that have a product of -24. So that means we're going to multiply two numbers to get -24. And the sum will be the middle term, which is +2. So I need two numbers to multiply to give me -24, add together to give me +2. Now remember, when we multiply two integers and the product is negative, or the answer is negative, that means that one of the integers has to be positive and one of the integers must be negative. No other choice. That's the only way to get a negative answer when we multiply two numbers. One positive, one negative, because if they're both positive or both negative, we'll get a positive answer. So what we need to do is factor this. So I'm just going to make a copy of this, put it down here. So yesterday we worked through some examples of factoring, and we looked at, scroll back up so you can see what I'm talking about. So we looked at some examples where we listed all of the factors and then we found the one with the right sum to give us that middle term. So all of these numbers right here multiply to give us 42. Oh, sorry, -42, and they all give you -42 when you multiply, but only one of them give you a +1 when you add the two numbers. And that was -6, +7. So it's kind of the same thing right here. Now, hopefully you've gotten to the point where you don't need to list all of the factors. So we're going to start with bracket. Oops. Insert an equation first. So we are going to start. Let's get into here and make that red. So that's going to be, okay, X. So, oops. So we know that, as I said, if this product is negative, a negative number, that means that one of the numbers inside the, one of the numbers in the binomial will be x plus something, and one will be x minus something. Okay, let's try this again. Equation. Okay, we're going to put that on the left, and we're going to make it red. So bracket x, and we're going to go plus a number, and then we're going to go x minus. Now I say a number, but I really mean an integer. So these numbers have to be whole numbers. For the type of problems that we're solving, we can end up with numbers that are not integers, but that's a whole different ballgame. We're just worried about the ones with whole numbers. So -24, when we multiply, so we can go 24 times 1. Well, I can't get a +2 when I add or subtract those two numbers. 12 times 2 won't work. 8 times 3, I can't get 2 when I add or subtract. 6 times 4. Now 6 and 4, if I add or subtract, I can get 2. So 6 and 4 is 20. So those are the two numbers I need, 6 and 4. Now the middle number we get by adding. So if the middle number is positive, that means when we add, the bigger number's got to be positive. So x plus 6, x minus 4. Now, if you're not quite sure, or if you're not quite following what I'm doing, then go back and do them like so. Like this example here. List all of the factors, and then do all the multiplying, make sure you get them right, and then add the two integers together until you get the right one. Okay? Um, but to speed things up a little bit so we're not spending too much time here, we're just going to do it this way. Now, in mathematics, the only way to get 0 when we multiply two numbers is one of the two numbers has to be 0. It's the only way. Okay, so that means that either x plus 6 is equal to 0 or x minus 4 is equal to 0. So let's do it this way. Either, oops, and let's make that an equation. And let's do this. So it means either x, I'm not sure what it's, oh, let's try this again. It's not quite working the way I want it to. Never seems to today. I don't know what's going on today with this. So let's try it again. Put another equation in there. And make it red. And so that means that either bracket x plus 6 is equal to 0. X plus 6, okay, is equal to 0. Okay. Or it means that x minus 4 is 0. Okay. So that means if x plus 6 is equal to 0, when we're adding, then x must equal, let's do it this way. Insert. How did they, okay, sum them up here. So x minus 5 equals 0. So x plus 6 equals 0. That means that x must equal negative 6 or x equals plus 4. Okay, so I'm just going to move these things over so they're lined up underneath properly like this. So if x plus 6 equals 0, and what I'm going to do too, we don't really need to put the brackets there in this. So the first one, we can get rid of the brackets there. Just go x plus 6 is equals 0, and we can do the same thing here. X minus 4 equals 0. Okay, so that means x equals negative 6, and x equals 4. So therefore, the roots are x equals 4 or x equals negative 6. So I'm just going to copy these and put them in here. And I'm going to make this not bolded. And then red. Therefore, the roots are x equals negative 6 and x equals positive 4. So what that tells us is that the x-intercepts are negative 6 and positive 4. So this, if I were to graph this equation here, y equals x plus 6 times x minus 4, come over here, oops, and I graph y equals bracket, where's bracket? X minus 6 times x plus 4. Okay, I'm going to get this one up here, get rid of that one. So y equals x minus 6, x plus 4. Where does it cross the x-axis? Crossing the x-axis at negative 4 and positive 6. So let's come back over here. What did we say? Negative 6, positive 4. Actually, this is negative 4. Actually, let's come back over here. Let me just check something here. So when we graph x plus 2x minus 24 is x plus 6 times x minus 4. I had the signs wrong. It should be x plus 6 and x minus 4. Okay, so there we go. Crossing the x-axis at there and there. So if we come back into here, I'm just going to show you something. This is really neat. If I come back into here, and the original equation was y equals x squared plus 2x minus 24. I don't know if I can copy that and paste it into here or not. No. So that would be, I'm just going to show you, this is really neat. Y equals, now if I come back into, what was the equation? X squared plus 2x minus 24. X squared plus 2x minus 24. Press enter. Oops, 24. That's not 2. Oops. I'll get there eventually. Look at this. So if I graph this one, y equals x plus 6 times x minus 4, my x-intercepts are negative 6, positive 4, negative 6, positive 4. This one here crosses the y-axis at negative 24, right there, 0, negative 24. But look, this is the green one. This graph here is the purple one. Green, red. Sorry, green, purple. Green, purple. What do you notice? They're exactly the same parabola. So this equation here and this equation here gives you the exact same graph. And what's even neater is in the first lesson, we learned about the vertex form of the equation. And the vertex form of the equation is y equals, so if I do this, y equals, and bracket x. Now, the vertex form gives us, the vertex is minus 1, if I look down here, minus 1, minus 1, minus 25. So remember, inside the bracket, we got to change the sign. So it's going to be x plus 1. We need to square that. And then minus 25. So now we have 3 equations in equation editor, or sorry, in Desmos. Green one gives us, so this equation here, y equals x plus 6, x minus 4 gives us the green graph. Y equals x squared plus 2x minus 24 gives us the I'm guessing that's purple, and y equals x plus 1 squared minus 25 give us the red one. And all three produce the exact same parabola. Okay, so the thing we're trying to get at is there are going to be times when we're going to want to use the vertex form of the equation. There may be times when we want to use the second one where it's just a trinomial, and there are times when we want to use the factored form to find the intercepts. Okay, depending on, now right now we're just looking at graphs. We're going to look at a bit later some problems, word problems that we're asking you to solve that involve the use of parabolas, and we'll have to determine which one of these equations is best to use to solve the problem we're asked to work through. Okay, so let's come back over into here. So that's how we find the roots or the x-intercepts or the zeros, okay? So let's take a look at one that's slightly different now. So part B, it says find the roots of y equals negative 5x squared plus 10x. This is not a trinomial. So because it's not a trinomial, we can't solve it the way we did in part A. So what we are going to do in this particular one is we are going to, now it's not a trinomial, so it's a binomial, but we can common factor. Okay, so let's start by common factoring. Okay, the binomial. So common factoring, we have to find things that are, I'm just going to fix this here now. And don't need to bold it. Okay. So the binomial is minus 5x squared plus 10x. And then because we're asked to find the roots, we have to set that equals 0. So the y value must be 0. So I'm just going to copy this part right here to make it a little bit quicker when I get down here. So I'm working the same problem, and left. So now we have a negative 5x squared plus 10x equals 0. So now, if we look at we call them coefficients, so the numbers that are in front of the variables, x squared and x, we have negative 5 and a positive 10. Now, we need to know our multiplication tables for this. So what will divide into 5 and divide into 10? Well, we always take the negative sign in front of the first one if we can. So we can common factor. So let's do it this way. So we can common factor a negative 5. And you notice there's an x squared and an x term, so we can common factor an x out as well. Then we're going to put a bracket. Negative 5x squared divided by negative 5x is x, because negative 5 divided by negative 5 is positive 1. X squared divided by x is just x. Positive 10 divided by negative 5 is negative 2. And we've common factored the x out already. So that's going to be equal 0. So just like here, if we're multiplying two numbers and the answer is 0, then that means that one of the two, or possibly both, have to be 0. So that means that either a negative 5x, this part here, either that is 0, so negative 5x is equal to 0, or x minus 2 is equal to 0. If a negative 5x is equal to 0, 0 divide each side of the equation by negative 5, then x is going to be 0, or x is going to be 2. So that means that if I were to draw a graph, okay, if I were to plot this on a graph, then what am I going to get? So the zeros are 0, or the roots are x equals 0 and x equals 2. So minus 5x squared plus 10x. Come over here. Let's get rid of this here. We'll go y equals a negative 5x squared plus 10. Let's come back over here. X minus 5x squared plus 10. That's the original one. Where does it cross the x-axis? Let's come back over here. Minus 5x squared plus 10. So minus 5 comes out. 10 divided by that is x is 2. X is 0. X equals 2. Minus 5x squared. Let's come. Something is not working out here. Minus 5x squared plus 10. Is that the original equation? Minus 5x squared plus 10. Oops. Minus 5x squared plus 10. So crosses the y-axis at positive 10. Oh, sorry, I forgot the x. There we go. Now it makes sense. So minus 5x squared plus 10x. And we said that the zeros across the x-axis at 0 and positive 2. Come over here, crosses at 0 and at 2. So by looking at, we can figure out the x-intercept. Now, if we look at this one too, we know this graph opens downward as well, because the number in front of the x squared term is negative. So that's how we determine the roots. So now let's try a one that's a little bit different still. Let's get it down here. So right now we have solve 4x squared plus 4x minus 8. So in order to solve these, it needs to be equal to 0. So what we are going to do is we are going to, in this particular one, I'm going to go and left. Okay. So we need to this is being not cooperating now. So what we need to do is go 4x squared and square that number. Come into here and 4x squared plus 4x. And then what we're going to do is to solve this, I need to get rid of the 8 to make that a 0. So to make that a 0, I need to subtract 8 from that side of the equation. If I subtract 8 from that side of the equation, I also need to subtract 8 from that side of the equation. equals 8 minus 8. Okay. Move this over here. Actually, let's put it here. And then it's too far. No, let's do the undo here. And they're going to make this red. So what I've done is I'm making this 0. So to make that 0, I need to subtract 8 from the other side of the equation. Now in mathematics, whatever you do on one side of the equation, if you're changing anything, you must do on the other side. So we subtracted, so I'm just going to highlight it here. So I'm subtracting 8 from each side of the equation. So it's still balanced. So now we're going to end up with, come down here. Now we're going to end up with 4x squared plus 4x minus 8. So it doesn't need to be highlighted anymore. And that's going to equal 8 minus 8 is 0. So now we have 4x squared plus 4x minus 8. Now in order to factor a trinomial, the x squared term must be, or the number in front of the x squared term has to be a 1. Okay, so what we need to do is common factor the 4. So I'm going to put that in a bracket over here. So now common factor 4. Okay, so that's what we're going to do. So when we come down here, what does that leave us with when we common factor the 4? So let's get into here again. Come here, red. Okay. So now we're going to have common factor a 4. So that means now I have to divide everything inside the bracket by 4. So 4x squared divided by 4 is x squared. So let's make sure we have that squared. 4x divided by 4 is going to be plus x, and then minus 8 divided by 4 is 2, and then that's going to be equal to 0. Okay, so let's tidy up how it looks here. Doesn't need to be bolded, and it needs to be red. So we common factor the 4. Now we're going to factor the trinomial. Factor the trinomial. So to do that, okay, we've already done a couple of examples like that. So the 4 will remain, and that will just be the stretch for compression factor. But we're not too interested in that right now. We're just interested in what the intercepts are, what the zeros are. Okay. So that's going to be 4 bracket x. Now again, the last number is negative, so that means that one of the numbers has to be positive and one has to be negative, and that's going to equal 0. So what two numbers will multiply to give me -2 and add together to give me +1? Well, one negative, one positive. The middle number is positive, so the bigger number's got to be positive. So that's going to be 2, and then x minus the 1. So if this is equal to 0, we're at this part right here now. Okay. Let's come here. So that means, let's make some room here. That means that either x plus 6, I'm sorry, x plus 2 is equal to 0, or x minus 1 is equal to 0. If x plus 2 is equal to 0, x must be negative 2. And if x minus 1 is equal to 0, x has to be 1. So those are my two roots, or the two x-intercepts, or the two zeros. Okay, however you want to say it, it doesn't really matter. We usually say the roots are x equals negative 2 and x equals positive 1. Now, again, if we graph this here, y equals 4x squared plus 4x minus 8, 4x squared plus 4x minus 8. So let's just change this. 4x squared, I think it was plus 4x minus 8, was that what it was? 4x squared plus 4x minus 8. So we said the x-intercepts are negative 2, positive 1, which is across the x-axis, negative 2 and positive 1, which is across the y-axis, negative 8. There's the number at the end that gives us that, the y-intercept. Okay, so if I were to, I'm not going to do it because we're going to run out of time, but if I were to come back into here and I were to graph this particular equation here, which I can't copy and paste for some reason, I'll try Command V and see if that works. Oh, I can. So if I do it that way, y equals 4 times x plus 2 plus x plus 1. I were to graph that, look what I get. Across the y-axis, this one here, green graph, blue graph, identical. So these two produce the exact same answer. So one of the things you can do when you're asked to solve an equation, for example, this one, and then when you work it out and you get the roots, if you want to make sure that your answer is correct, graph the two and make sure that the two graphs are identical. If they're identical, then you know you get the right answer. You can't be wrong. Okay. One more question if we have time here. Determine all the values of that should say x, italics. So that y equals x squared minus 4x minus 21 when y is negative 15. So if y is negative 15, let's see if we have time, then we're going to have x squared. I'm just going to copy this. Essentially what we're doing is this. And paste it in there, and I'm going to make it red. So y equals x squared minus 4x minus 21. Okay, and I'm going to make it all red. Okay. Oops. Why does it do that? I don't know. Let's put on, doesn't want to go to the left-hand side for some reason. Okay, so when we solve that, y is negative 16. So all we're going to do, we're going to change y to a negative 16. So let's do that. So now we're going to end with negative 16. Oops, it's doing weird things right now. We come down here and go get rid of that to the next page. And we're going to go negative oops, an equation. And let's make it right. So 16 is equal to this right here. Okay, so now what we need to do is, in order to solve this, we got to set this equals 0. So I need to subtract 16 from this side of the equation. So I'm just going to copy that. Oops. Make that a copy and then come down to here. And it's not cooperating today at all. It's just being a pain. So I'll click the undo button. Let's come back up here. Try it now. So we are going to subtract 16 from that side of the equation to get 0, and then subtract 16 from that side of the equation to get 0. And I'm noticing a problem already. Not really a problem, but this is not going to work out the way I had intended. Oh, sorry, no, this is y is negative 16. There we go. Now it will work. So now I need negative 16. I need to add 16 to make it 0. And if I add 16 to that side of the equation, I need to add 16 to this side of the equation. So now I'm going to end up with, okay, I'm just going to copy this again, go down below it. Okay, and back up. So now negative 16 plus 16 is 0. Okay, that's gone. 0 equals x squared minus 4x minus 21 plus 16 is minus 5. So now we have to common factor this part. So to do that, let's go into here. It's not squared anymore. So we're going to have a bracket x. The last digit is negative. Oops. So we know that 1 is going to be negative something, and 1 is going to be positive x plus something. Okay. So get a negative 5 when I multiply, and negative 4 when I add. So it's going to be negative 5 x plus 1. And so that means either this is 0 or that is 0. So that means that, now I'm not finding the roots this time though. Keep that in mind, okay? As this is a different problem now. So either x minus 5 is equal to 0, whereas x would be, in that case, x would be plus 5. One way to get 0. And then if x is x plus 1 is 0, then x would have to be negative 1. So what they're saying here is If I were to graph this and I look at where y is negative 16, okay, so let's do that right now. X squared minus 4x minus 21. X squared, did we say it was again? X squared minus 4x minus 21. Minus 4x minus 21. So when x is, we said, what are the values of x when y is negative 16? When y is negative 16, and just pull us down, come back up here. When y is negative 16, which is right here, x is negative 1 and x is positive 5. What did we say? Negative 1, positive 5. So this problem is slightly different than the ones before. We've gone a little bit over time today, but that's good. So we're done for today, and I look forward to talking to you again next week. Bye for now.